Neanderthals or Neandertals, named after the Neandertal area in Germany, were a species or subspecies of human in the genus Homo, which became extinct around 40,000 years ago. Neanderthals are generally classified by paleontologists as the species Homo neanderthalensis, or alternatively a subspecies of Homo sapiens, Homo sapiens neanderthalensis. Several cultural assemblages have been linked to the Neanderthals in Europe. The first humans with proto-Neanderthal traits are believed to have existed in Eurasia as early as 350,000–600,000 years ago, with the first true Neanderthals appearing between 200,000 and 250,000 years ago. The exact date of their extinction had been disputed, but in 2014, a team led by Thomas Hyam of the University of Oxford used an improved radiocarbon dating technique on material from 40 archaeological sites to show that Neanderthals died out in Europe between 41,000 and 39,000 years ago. Heidelbergensis originated between 800,000 and 1,300,000 years ago, and continued until about 200,000 years ago. Between 350,000 and 400,000 years ago, the African branch is thought to have started evolving towards modern humans, and the Eurasian branch towards Neanderthals. At some Levantine sites, Neanderthal remains date from after the same sites were vacated by modern humans. This implies Neanderthals were better adapted biologically to cold weather than modern humans, and at times displaced them in parts of the Middle East when the climate got cold enough. One such example is Rhodesian man, Homo rhodesiensis, who existed long before any classic Eurasian Neanderthals, but had a more modern set of teeth. Edward Rubin of the Lawrence Berkeley National Laboratory states recent genome testing of Neanderthals suggests human and Neanderthal DNA are some 99.5% to nearly 99.9% identical. This research compared the genome of the Neanderthals to 5 modern humans from China, France, Sub-Saharan Africa, and Papua New Guinea. Since the 3 known African genomes show a similar proportion of Neanderthal sequences, the interbreeding must have occurred early in the migration of modern humans out of Africa, perhaps in the Middle East. Gene flow from modern humans to Neanderthals would not be expected if contact occurred between a small colonizing population of modern humans and a much larger resident population of Neanderthals. While interbreeding is viewed as the most parsimonious interpretation of the genetic discoveries, the authors point out they cannot conclusively rule out an alternative scenario, in which the source P. population of known African modern humans was already more closely related to Neanderthals than other Africans were, because of ancient genetic divisions within Africa. One of the major findings focused on the limb morphology of Neanderthals. According to a 2014 study by Thomas Hyam and colleagues of organic samples from European sites, Neanderthals died out in Europe between 41,000 and 39,000 years ago, and Homo sapiens arrived in Mediterranean Europe between 45,000 and 43,000 years ago, so the 2 different human populations shared Europe for several thousand years. This would suggest that modern humans came in and replaced Neanderthals, rather than a slow shift or integration occurring in this region. In November 2011, tests conducted at the Oxford Radiocarbon Accelerator Unit in England on what were previously thought to be Neanderthal baby teeth, which had been unearthed in 1964 from the Grotta di El Cavallo in Italy, were identified as the oldest modern human remains discovered anywhere in Europe, dating from between 43,000 and 45,000 years ago. Some researchers suggested mixture of 3.4–7.9% in modern humans of known African ancestry, rejecting the hypothesis of ancestral population structure. While modern humans share some nuclear DNA with the extinct Neanderthals, the 2 species do not share any mitochondrial DNA, which in primates is always maternally transmitted.